Hello and welcome everyone. In this day 16 of linked list learning, yesterday we have looked at uh, linked list introduction. Now this session is going to be focused on singly linked list, where we are going to look at what is a singly linked list and a general uh, definition of a node object or a node class and different operations on the singly linked list, such as insertion, deletion, or traversing through a linked list, or reversing a singly linked list if possible, right? So let's get started. Firstly, what is a singly linked list? So singly linked list is a data structure of type linked list where there is one directional connections. That means there is node, node pointer along with data. That specific node is defined with. And there is only one directional flow, which means there is no circular or bidirectional pointers between two nodes, right? There are in future we are also going to learn doubly linked list, circular linked list as well, right? So now I would also like to show how a simple class of node looks like. So a node object or a class would look like this, where constructor, and there would be value, okay. So this is how a simple node would look like. It would have value and a next pointer, right? So we can say this can be a null value at this moment. Okay, so as I was saying, an example of linked list would be, let's say, a value 15 connected to 3 and 3 connected to 47, 47 connected to 78, right? Let's say this has head and this to be null, right? So the memory allocation might be different between these two. So as we discussed in the linked list topic, and the way to access this is we start at head and we access the next node and this next node, right? And we obviously know that we cannot access an in between element in the first go, or in O of n time complexity. We will have to start from the head and identify the required node that we want to. So the different operations that we are going to look into is with respect to singly linked list are insertion, and insertion at beginning and insertion. So insertion with start of the node, that is head here, and end, that is just before this null, and third one middle or some pointer, right? This can be anything. It can either be here, here, or here, any middle pointer. So let's see how we can do this. So at the start, we so what we can do is we can say we can define a new node. First one, inserting at start of a node, we can insert a new node. Uh, we can say this dot head is equals to new node, and before even having to assign this new node value directly to this one, we can act this as a temporary space to have this dot or head assigned to the new node. And once this value is defined, then we can have the head value assigned to the new node. So eventually what we are doing is we are saying head to be linked to new node, right? So we have a new node, let's say of value uh, say 5, and we want this to be pointed this way. So which means we are eventually going to break this loop, and we are directly going to have this one. So we are firstly having to assign this with the head value head node, and then the head value point to the new node. At the end, we are having to establish this connection instead of head being pointed to the next node, right? So this time complexity of this part would be uh, O of n or O of n, and the code for the same I am just going to switch to the JSBin editor to show the code how we implement it with a linked list class. So here if you see, this is gen- this is a simple node that we are going to use for the linked list nodes. And here initially there would be, whenever we initialize a linked list, then we start off with an head value null, and we have here insert at the start, which takes in a value and puts it into a new node, and then we say new node dot next will be this dot head, and this dot head will be new node, right? Hope that is easier. And whatever the next pointer of this dot head will also be carried forward to the new node, and the linked list will continue to be traversed without any breakage, right? Similarly, insert at the end. So, so, so for insert at the end, we traverse till we find last node, and assign last node to new node. Let's do null. null. Okay, so uh, simple implement. Let's say we have few nodes, say 4, 13, 1, and this is pointing to null. So let's say these are the three nodes. We want to insert a new node 7 just before this one. So we iterate through, let's say this is head. We start from head and we iterate all the way till we find this specific point. And once we see this is pointing to null, we assign this to this one, and we uh, point the new node to null. So the way that we do it is we let me switch to the Chrome browser to show the code. So here we have inserted the end function. So in this function, we are assigning this new node with a value, and we are checking if this is like a safety check. If there is no, if the head doesn't have any nodes, then we assign this dot head to the new node and we simply return. Else we uh, take a temporary current pointer and we assign this to head, and we move this current pointer till we reach the last node where the value becomes null, and then we finally assign this to the new head value, right? So this is how we do it. Okay, so next we are going to be understanding how we do it, how we do an insertion in the middle, right? So yeah, so before we start uh, understanding how we insert at middle, the time complexity of this one is O of n, as we need to iterate through the entire linked list. And now let's understand how we insert a node at the middle, right? Uh, this is the third operation with insertion. Insert node at middle. Let's say we have few nodes, 7, uh, 11 and 28, and this is pointing to null, and we want to insert a new node after 11, right? So what we do is we say we give the node, we want to insert new node, let's say 33 after 11, and then this goes to uh, we establish this connection, and thirty-three after 11, right? So we would have a function, we create a function asking sending in this node that we want to insert. Or let me say, we say new node that we want to add, and existing node. So we pass in this existing node, and so let's say this would be our function. We pass in these two values to this function and pass in these two parameters, the new node that we want to insert and the existing node, which is 11. So how we do it is we assign the new node. We want to eventually say existing node dot next is equals to 33, but before even doing that, we should not be losing this pointer value. So we say existing node or new node dot next is equals to the existing node dot next, and then we assign node not next is equals to 33, right? So let me just show you the code, and it should be pretty much simple to understand, right? Before even going there, the time complexity of this kind of operation is obviously O of 1, right? So that is something that we will have to understand. Okay, now let me go to the JSPin editor to see the code implementation. So insert at a position, right? So we send in the new value that we want to insert and this position value. So if this position is 1 or doesn't have anything, then we insert at start, considering that there is no nodes. And if that is not the case and there is already a next pointer, then we uh, create a new node with this value, and we say this dot head, and we iterate till the position that we are looking to traverse. And once we reach the position with the temporary current pointer, then we also check if the current position is present, else we throw an error. Then we simply do these two operations, that is, the new node dot next is equals to current dot next, and current dot next we simply assign to the new node, and the next pointer from the position node will be assigned to the new node, right? And we assign the specific positional node to the new node value, which would contain the previous and the next pointer that it needs to fill in the linked list, right? Hope we understood the insertion operation. So I would still stay here and just walk through the other piece of operations, such as traversing through a linked list. So we traverse this way, where we assign the head to a temporary current pointer and we continue till there is the last node, which is null. And searching for a target, we return true or false, with this way checking if the current dot value has a target, then we return true, else we continue to iterate through the linked list. So we have already looked at insert at start, and similarly, with little bit of thought process, we can also come up with delete at start, delete at end, delete at a position, right? And count nodes will also be an easy thing to build upon. Reverse function is also pretty much easy, but yeah, you might need to do a little bit of thought process. Take it as a challenge and try it yourself. I will even share all the examples or this specific code snippet and how to use this to run this with a piece of execution statement on how to use this linked list. So in the meantime, I'll try running this. uh, so firstly, we are inserting few elements at the start: 30, 20, and 10, 10, 20, and 30. So if we insert 10, this gets inserted at the start. Let's see, just understand what is happening. So, and list.traverse would give us this way, and insert at the end would give us something like this, adding 40, 50. Insert at a specific position, that is number 3, would append 25 before 30, and search for 30, and these search functions here would return true or false. And delete is another function that is very similar to insertion. You can uh, understand it very quick with minimal effort from your side, right? And reverse is a function that you can try on your own. I will share this code with you in the description. You can find it, right? Please do let me know if you find anything tricky or any clarifications on this topic. I would be happy to help. Hope you found this video helpful. Please do like and subscribe to my channel. Thank you.